Hi everyone. It's funny you mentioned the Ars Electronica. It was in my previous cycle of life when I was still working with technology. But yeah, now I'm working mostly with biology systems. And as you mentioned, I'm the co-founder of GenSpace. Can you hear me better? GenSpace? It's also falling down.
Better?
Yeah, is it better? So GenSpace is a non-for-profit community biotech lab. We're based in New York City, and we're dedicated to biological sciences driven by citizens and scientists while providing access to biology. We formed our group in 2009 and opened the lab to the public with our facility in 2010, with a very rich programming, including educational, cultural, outreach programs, as well as creating a platform for scientific innovation, creativity, and independent thinking. My prime artwork, though, in the last couple of years, is situated in a biology lab and spanned from working with an intelligent bacteria found by Professor Eshel Ben Yaakov from Tel Aviv University, which greatly inspired my artwork, especially his research about the social life of bacteria. And working with live organism taught me to slow down, to embrace chance and serendipity over control, to look at rather than to look for, and to better understand questions, convictions towards natural and design, organic and non-organic, hierarchies in nature, decay, and life itself. Working with a smart bacteria taught me to reach out to nature and learn from models of communication, structure, and behavior, which exist for billions of years. In my artwork, I do not wish to tell stories about science. For me, working with biological systems hands-on is vital, and I see the lab as my studio space, where I can explore traditional scientific processes through artistic inquiries, and the gallery or the museum space, where I can share and create access to experiments that are often done behind closed lab doors. Or rethinking novel biomaterials and living systems as our new building blocks, from futuristic forms, structures, and methodologies in the lab to environmental awareness and responsibilities, both as an artist and as a citizen, and advocating interdisciplinary art, biology, technology practices, DIY bio, and citizen science. I've collaborated over the years with numerous scientists and organizations and developed programs to link art science at community labs, at universities, and also within my own artwork practice, trying to bring biology in a creative way, you might say, examining the practices and the ethical or possibilities out there in the biotech realm. So in the same year that GenSpace opened its doors to the public, Rob Carlson published his book, Biology is Technology. And back then, both our lab and the statement seemed far-fetched. Today, we see biotechnology as the new promise, the new revolution, with all its wonderful possibilities and promises from tissue culture engineering and genome editing to biomaterial fabrication and synthetic biology. But then you might ask, what could you do in a lab? So just to give you a speedy background to some of the biotech promises, from speculative to some that are already in practice. Biotechnology is one of the fast-growing fields out there, with footmarks in every aspect of our lives, with potential to replace energy resources, for example, lab-grown algae, to the revolution of genetics and molecular biology, or personal medicine, from mapping the whole human genome to mapping microbiome on and in our body, as well as mapping the microbes in our environment, and the recent race to map our brain, as well as the use of social networks or crowdsourcing, either 23andMe for genome that was mentioned, or the American Gut Project for microbes, for example. It was also mentioned here already that today, with this technology, we could read and write DNA, and it's cheaper and more accessible. If it took a decade and $3 billion from American taxpayer dollars, parallel to Craig Venter's private enterprise, now we can do it in a day and for less $1,000. And with the use of the engineered CRISPR-Cas9 system, bioengineering is in the tip of our hands. We witnessed the revolution in medicine and genetic engineering. We now use the cells as our factory workers, so we can start talking about labor in a new term, and DNA as a programming language that can control living systems. To grow our materials in the lab, from drugs like the artemisinin ear that is resistant to malaria and is extracted from the Artemisia plant to grow in bacteria, to everyday products. We use synthetic biology to manufacture or grow new materials, and the promise of the spider silk growing strong materials in goat milk, while on the way using animals as host to the synthetic biology industry, has now realized and manufactured by bulk thread and Spiber. So we're starting to think about proteins as an industrial material the same way we think about metal or glass or plastics. We can now fragment nature into its building blocks or the nanomolecules and reassemble it back all together. And we can also see biotechnology footmarks has entered our homes and our kitchen tables. As you all know, genetically modified food has been around since 20 years, with the first savor-flavored tomato back in 1994. And since then, whether we accept it or not, most of the crops use GMOs, especially for herbicides or pathogen resistance, called by some biological treatment to replace chemical treatment, as well as fast growth or better nutrients profiles. We engineer drug for medical purposes, but also for purposes of human body enhancement. Playing on the metaphor again, if the genome is our software that could be rewritten, then our body is the hardware. If we can engineer our software, we could also engineer our hardware, which brings us to ask, where does it put our body 2.0 in today's biotech world? And who can actually afford it? Advancements in stem cell research, in vitro and tissue culture engineering practices, we're starting to think about fabricating or even growing body parts in the lab. First, for medical purposes, to replace organ transplants from skin tissue to blood vessels, kidneys, lungs, hearts, bone. From the use of bioreactor to 3D printers, as well as integrating electronic technology into it. So then we can start rethinking the limits of the body, the natural versus the artificial, the extensions of the body, and even extensions of the brain. And now that it's fashionable to talk about VR. But then we can also think about using this technology for non-medical purposes per se. So we can say, Gattaca is here. If we can engineer and design our genes for treatment in genetic diseases, we could potentially use the same technologies to design or improve other traits, like height or weight, or even perhaps intelligence. So the use of gene banks and gene therapy to design new genetic circuits, or even design our future babies, imagining a scenario that parents would go through being asked, how would you design your future child? Which also brings us to ask again, are we indeed entering an age of genetic vending machines or genetic apartheid? We see biotechnology affecting social and legal forms, from gene patenting, biotech startup nation, IP money pool, DNA fingerprinting is now used in courts as evidence, to privacy issue and identity theft versus crowdsourcing for research and transparency. And I'm really happy that the last two talks also brought up consent, informed consent, talking about the HeLa cells in that term versus 23andMe, or maybe both of them. And it's also interesting to make the notions between share and see, and perhaps we can talk about it later. So who in fact has the ability and access to all these wonderful things and to tinker hands-on with all these biological machines and technologies? Is it only scientists, universities, private pharma, government agencies? So at GenSpace and other DIY bio communities, we believe that everyone can and should be part of this revolution. Take part in a conversation, in public debate, take part in decision-making, in ruling, in ethical standpoints, and directly take part in lab experimentation, in research. And at GenSpace, when we set off to build a place where people from all walks of life can come and learn, discuss, exchange ideas, and experience hands-on wet lab scientific practices. And just like cooking, it's not enough to have access to knowledge. At GenSpace, we believe that tangible experience is essential. In fact, more than just a physical space, we wanted to build a community for people, just like everyone here in this room, so we can become a more knowledgeable, aware, and involved citizens. From maker movement, cheap and accessible biolab tools and equipment, to open labware or 3D printing your own lab equipment, or now growing your own lab kits. And with the Arduino and the 3D printer revolution, makers are now able to create cheap lab tools and equipment like the Open PCR and Open Fuge, or DIY microscopes, gel electrophoresis boxes made from plastic containers, 3D printer pipetters to the Spiker kits, or the OpenTron, a 3D robotic arm for automated lab protocols, to the recent portable all-in-a-box, the Bentolab project combining centrifuge, PCR, gel electrophoresis, all into a portable bento box sized tabletop machine, or the BioCurious collective bioprinter for living cells, or their sister portable projects like the Amino Labs or BioRealize, to a portable DNA transformation kit, or the Spiderwort, which is an open CO2 incubator for personal tissue culture and for less than $1,000, which is pretty amazing. We also build communities so we can share information, protocols, and resources, either on our community websites, using social networks, or meeting in person and peer-to-peer teaching each other how to do it. From open source science and the MIT Open Wetware, to social media like YouTubes and Facebook and Instructables, to organizations such as the BioBreak Foundation and iGEM competition, Hacketeria, Backyard Brains, or the BioBuilder Synthetic Biology Lab book, to local community lab websites and listings. One of them is the GenSpace project, the Open Lab project, that is publishing detailed instructions how to set your own lab, should you be interested. Today there are about 90 groups all over the world recorded on the DIY Bio website, a growth of almost 30% per year since the start of the organization in 2008. Each group has its own individual flavor, which grew out of their community, and they all share either the need for a physical space, or if limited with budget, a virtual platform for discussion, for sharing knowledge that would support open science, innovation, transparency, public awareness, and practice. And these days, there's a group of DIY Bio in Israel. They're forming under the name of BioHub IL. And they have already found a place and managed to collect much equipment through donations. They have established a meetup, so they meet every Monday in their space, and coming January 10th, they are going to host their first CRISPR class for less than 400 shekels, which is less than $100, and ridiculously cheap for 10 sessions. So I highly recommend to check their website and their Facebook for those who are interested, where they regularly post about their activities and ongoing discussions. So, while community labs open in cities around the world, biology graduate students who were interested in independent research adopted the movement ethics and established mini labs in their bedroom closet. That was at least at the beginning of the movement. I don't know how much it is done today. The movement's ethics and practices inspire citizens to engage with their local communities. So while high school students in New York City barcode the DNA of mislabeled cheese in a local deli found to be cow milk instead of goat milk, or identifying the fish used for the sushi in the local restaurants to be tilapia instead of a tuna, which is known as Sushi Gate, or citizen scientists of the DIY Bio in Berlin group played detectives to track down a dog owner who didn't clean after his dogs and confronted him after matching the DNA of the found artifact. Yet before citizen science lab have popped up, artists too have pioneered methods and practices, including in biology. And in the lack of traditional biology lab available, New York City artist Amy Chase, for example, has collaborated with molecular biology Christine Baldwin to grow bacterial drawing in her kitchen using her stove to make agar and an electric blanket instead of an incubator. Pioneer artists Oron Kutz and Yonat Zur, who are here with us today, founded their own lab in Western Australia University, Symbiotica, which is the first biology lab by artists for artists. Invited artists to create new projects in their lab back in 1996. That's 20 years ago. And later also established a unique bioarts program, which they have since helped to open in Helsinki and in London. They've also pioneered bioart practices with tissue culture engineering and coined the term semi-living, bringing awareness to in vitro culture, living cells, or redefining terms such as life as we know it today. Other artists, like the pioneer Joe Davis, has collaborated with labs at MIT and Harvard, where he's a resident since the 80s. In Microvanus from 84-85, he codes a message in a bacteria DNA. That's 30 years before Craig Venter coded his name in the first engineered bacteria back in 2013. There is a misconception that artists' work is to tell the stories of scientists, but artists have their own stories to tell. Today, many artists establish their own spaces or work in universities. Artist Paul Venus, who founded the Coalesce Center for Biological Arts at Buffalo State University, has questioned scientific authority through their interfaces in his own artwork. He hacks PCR technology and rethinks the electrophoresis gel box. Working outside the box, Venus designed new DNA parts and the interfaces in which we read them to draw on DNA manipulation and the authority of scientific reading as truths or as facts. Artist Heather Dewey Hagberg, a GenSpace member who came to GenSpace with no previous skills in synthetic biology, extracted DNA from gum, hair, and cigarette butts she found on the street, came back to the lab, sequenced them, and then 3D printed portraits based on profiles she compared with the FBI's database, inspiring us to think about the DNA we leave behind, DNA fingerprinting, DNA spoofing, and privacy issues. Her project inspired many scientists, thinkers, and even law enforcement, but one that really stood out is The Face of Litter, a street poster that was set up in Hong Kong in 2015 that was using DNA analysis to publicly shame litter bugs. So we see how artists inspire the city, and going back to tissue culture engineering and other biomaterials, we also see how artists inspire the industry. Back to Yonat Zur and Oron Kutz, project Semi-Living Steak from 2000, which is the first lab-grown steak grown from prenatal sheep cells. That's more than a decade before Mother Meadows, a Brooklyn-based startup that was founded in 2011, is now claiming to grow industrial synthetic meat and leather in their lab, and the local Israeli super meat to grow lab-made chicken. So we also see artists invited by biotech companies as artists in residence. Epibone, a Brooklyn-based startup that grows human bone tissue for skeletal reconstruction for medical purposes, opened its lab doors and invited artists as residents. And here you could see Maya Ishida, the first Epibone artist in resident that grew lab bone jewelry inspired by cross-sections imagery that was used at Epibone. And last year I was invited to develop a project with them, thinking about bone as a new biomaterial which could be grown in the lab for non-medical applications such as design or art projects. So in this work I created lab-grown buttons which drew attention to early domestic design tools and transformation of materials extracted from their origins and become practical objects. I was invited to do research, explore and test environment, rethinking various scaffolds, material, the lattices, the form, and biomaterial modification from natural bone structures to 3D printed simulations in collaboration with Autodesk. Later, I also invited Epibone founder Nina Tandon, artist Maya Ishida, and Chris Venter, who was at the time working at the Autodesk BioNano Research Group, to share our processes with the public in the form of a workshop at GenSpace. We see the use of 3D bioprinting in novel biomaterials, and one of my favorite is Enrico Dini 3D printing coral reef that he designed and placed back in the ocean to prevent coastal erosion. We also witness biotech revolution inspire us to rethink the potential to replace material resources or slaughter animals. Here, the Seattle-based company Pambient is growing rhino horn and elephant ivory in their lab. We also witness how the biotech revolution inspire us to rethink the potential to replace industrial manufacturing and resources that we dig from the ground with renewable resources and fabricate materials that lab-grown biomaterials. Pioneer artist Phil Rose, who is working with fungi in his artwork for over 2 decades, has inspired both artists and designers all over the world, as well as companies like Ecovative, based in upstate New York, who grow environmental friendly packaging mixing waste and mushrooms to replace styrofoam, for example, while Ross himself recently established his own company, MycoWorks, to develop industrial material from mycelia, such as fabrics and leather-like materials. So we are starting to see artists not only inspiring culture and industry, but are becoming part and in fact leading the industry. Or the use of SCOBY, the waste of the kombucha drink in fermentation, used by British designer Susan Lee, who too has an inspiration in lab-grown fabrication. In her work Biocouture, she grows clothes in her lab with the Acetobacter cellulose. She also inspired other artists like Ali Schachschneider, a previous student, to grow a second skin, or biodegradable Gen2C, the collaboration between GenSpace and the architecture team Terraform One. Another project by a previous student, Sylvia Sobrio, who hacked the process of bacteria painting and used traditional printmaking and genetically modified bacteria to create these lab-grown tiles in her work Vivo. Or artist-designer Natsaya Drichaise is using bacteria's natural pigmentation to dye her silk fabrics. And we can also see Pili Bio, a startup company that was founded by Thomas Landring, who is also the co-founder of La Paillesse, the Paris Community Biolab, manufacturing environmentally friendly bacteria ink for industrial use, from natural pigmentation bacteria. So it's important for me to introduce these artists and scientists' processes and methodologies with the public, and to create awareness through educational program and bridge science in a creative way. In 2012, Ron Katz came to GenSpace to give a workshop in tissue culture engineering to our community. When I first started working with biological systems, and I co-founded GenSpace so I could work independently as I do in the studio, and I was looking for a space where I can develop my own practice, but a space that I could also share with others, a place where scientists and artists can collaborate and exchange ideas and learn from each other, and where I can invite other artists and scientists to share their processes with the public. Oron Enyonat, Joe Davis, Heather Judy Hagberg, Paul Venus, Phil Ross, Susan Lee, Natsai, Thomas Landry are just a few of the artists and scientists I invited to GenSpace to share their work in the form of presentations, residencies, or workshop programs that are now becoming standard common practice and a second nature in other community biolabs. And thinking about alternative education methodologies and collaborative opportunities combined with public participation and artwork practices, I've also started an outreach collaboration with scientist Christine Marizzi from the Cold Spring Harbor DNA Learning Center. Our first project, the New York City Biomap, part of the Urban Biomap project, is a multi-plate artwork made with bacteria modified with fluorescent proteins, where we invited the public to collaboratively create a map of New York City, drawing on the notions of our personal microbiome and our city collective urban biome. And a recent project at Aspen, we invited participants to create a multi-layer bacterial landscape with genetically engineered bacteria and 150 plates, creating an image of the iconic Maroon Bells Mountains, drawing on human interventions in nature and the relationships between the microbiome and its environment, or perhaps looking at yesterday's talk, maybe the new sublime and the fear from this new sublime or synthetic biology in general. I believe that the arts, and it's my last, so it's in time. I believe that the arts and the DIY bio community is in a unique position to explore social, moral, and ethical questions related to new biotechnologies through their work. And I feel this is an integral part of public engagement with the sciences, and perhaps in a not so far future, we will be able to see in every city a library, a fab lab, and a community lab, exploring art, science, technology, with linking threads to biology. Art-science collaborations may become a common practice, and maybe biotech labs may become social hubs with substantial impact on our public domain, informing citizens about science while informing scientists about citizens. So, thank you.